MOSFET has four electrodes: source, gate, drain, and body. For NMOS, source and drains are N plus type uh, semiconductor, and substrate has P type. So MOSFETs work as a switch. For example, there are a lot of uh, electrons in source, and electrons in source flow through the gate channel and drain to drain. In red line, there is no drain bias, and if we keep giving a drain bias positively, then the electric energy diagram would be lowered. So if we keep giving uh, giving drain bias higher, the threshold, the pinch off of the channel will be occurred. So at some point, current flows at same rate. So this is the definition of channel modulation. And MOSFETs has a MOSFETs consisted with a two MOSFETs. In source side, the how channels would be induced defined as difference between gate and source side voltage. If the difference between gate and source would be lower than the threshold voltage, there will be no channels induced. And if difference between gate and source is bigger than threshold voltage, there will be channel will be induced. However, in the drain side, because of the source side has grounded, the to current to flow through the drain source to drain must be positively biased. So the difference between gate and gate and drain would be different than the difference between source side. So the channels get narrowed and the saturations exist. So we're gonna look about a IDVD characteristics. The charge at channels can be defined as a how charges inversion through gate. So the carrier concentration is defined as product of effective density of states and Fermi level at channel surface. So in MOSFET, we learned about that at strong inversion, there will be a most voltage drop would be on oxide. So we can say like this, but because of drain bias, it's not valid. So if we look at the current density formula, the Qn can be defined with a channel charge or inversion charge, and the electric field would be defined with drift current because the drain to source has different potential. So if we the two transistor equations comes out, first of all, a current of drain would be defined with a difference between VDS drain bias. So if the difference between gate voltage and threshold voltage is lower than drain to source bias, then we will call it linear region. And if the drain bias is bigger, is smaller than a difference between gate and threshold voltage, we'll call it saturation region. The reason why we call saturation region is that before the channels potentials are different between source to gate and drain to gate. So as gate bias get higher, then the current will be derived more, but as drain voltage is saturated. In PMOS, if as gate bias goes lower, then the more current can be derived. So we're gonna concentrate on pinch off and which means a channel length modulation. So if there is if it drain side, if the difference between gate bias and drain bias is equals, then the pinch off starts, and then the depletion are exist, and the length of channels would be shortened. So there is a formula that it describes the short channel effect. And we're gonna look for the IDVG characteristics. As if we keep the drain bias constant, and if we vary the gate bias, if we if we keep getting a gate bias, keep giving a gate bias up, then the slope would be higher, and if we lower the gate bias, then slope will be flat like. So there is a equations as the drain bias keeps constant, there will be a first order equation varied parameters of gate bias. So using these characteristics, we can there is a lot of applications, but we're gonna look example for a inverter. If in gate side there is a variable voltage source, and if we give a gate bias logically on state, for example, like 5 volt, then the drain voltage would be lower than the VG gate bias. And if give the gate bias to off state, like low 1 or 0 volt, then the drain side would be gets lower, but drain bias would be high, so that we can the mobility of MOSFETs has a lot of different difficulty to move through channels. There is impurity scattering, lattice scattering, first of all, the impurity scattering, which also known as a Coulomb scattering, is caused by a ionized charge, fixed charge, and the lattice scattering is caused by a outer thermal energy. So in this chart, if in lower temperatures, the impurity scattering gets dominant because impurity is because if more fewer in if we dope it fewer, then the mobility would be good. Electrons move the easier, but the if we keep heavily dope the channels or substrate, it will be mobility would be lowered, and the others if and the temperatures keeps goes up, and there is a phonon scattering is dominant because the uh, as temperatures goes up, electrons free carriers can get a energy from the thermal energy. So it is harder to move because of the thermal energy. The operation mode of MOSFET has a depletion mode and enhancement mode. At depletion mode, the channels already induced before the gate bias and the enhanced mode, channels induced by giving a gate bias.